I was in the middle of reading this book for TBB before filming this video. I love this book so much such that I purchased 2 copies of this book. In this book, from chapter 17, Paragraphs Beyond the Basic, section Picking the best message type and limiting the number of messages implied. I was reading this part of the book before filming this video. If you scroll down, you can find figure 1712. In this example, they use STD shared PTR at this part, also at this part. But it occurred to me that I need atomic for shared PTR. Luckily, C++20 standard introduced STD atomic for shared PTR. Hi everyone, my name is Thomas Kim. Today is July 16th, 2022. This is my 28th episode for C++17 2023 CUDA, SQL, OpenGL, OpenCL, TBB. As you can see in this title, I will discuss low-level threading in C++ standard. I will discuss how to pass STD atomic and STD-REF reference to a function. STD atomic, STD shared PTR, and STD atomic reference are introduced to C++20 standards. In this episode, I will discuss STD atomic. In my next episode, I will discuss STD atomic, STD shared PTR. I will cover OpenCL. If you double-click this link, you can read more about OpenCL. OpenCL 3.0 is released in year 2020. OpenCL 2.2 was released in 2019. Also, in this link, you can read more about OpenCL. If you scroll down in the Chapter 7 device, you can find OpenCL 3.0 support. Here, Intel's 6th, 7th, 8th, 9th, 10th, 11th generation processors such as Skylake, Kaby Lake, Coffee Lake, Comet Lake, Ice Lake, Tiger Lake support OpenCL. Also, Intel Arc discrete graphics with the latest Intel Arc Windows graphic drivers. Intel Arc discrete graphic card will be released to the retail markets very soon. Also, some devices from NVIDIA support OpenCL 1.2. I am not much interested in OpenCL per se, but I need this tool because I want to learn data parallel C++, especially SQL. I like this book so much such that I also purchased 2 copies of this book. I would recommend these books listed here. For example, Heterogeneous Computing with OpenCL 2.0, this book. Also, this book. Also, this book. Also, this book. I cannot make any promise or commitment that I will film videos about OpenCL, but I am seriously considering learning OpenCL in depth. I would film 10 or 20 more videos about ProTBB. Then I will cover data parallel C++ with SQL shortly. Then I will turn my attention to OpenCL. I assume you have watched my previous videos listed here. Otherwise, you may not be able to follow my current and future sessions. Without further ado, let's get started. Open up Visual Studio Code. In your working folder, select empty space, click this button, 028 atomic. Click this button, atomic.cpp, hit enter, Ctrl B. I will close this file and paste some links for your convenience. Include talk play fun, types, HPP, include CPG, SCD, extensions, template, type name T, struct, SD is atomic, public, SCD, pulse, type. This is primary struct. Now we do specialization here. SCD, atomic, T. It should be true type. Template, type name T, context per auto is atomic V. We use this struct by passing T, then value. We need SCD, remove CBRAFT, like this. Template, type name T, concept, atomic, C. We call this function by passing T, or it can be bool. Void test is atomic V and atomic C. Int main, copy this function, paste it here. SCD, cout, SCD, bool alpha. Int A, 5. STD, atomic B, we can initialize, for example, with 0. STD, cout is A, an atomic, then we use is atomic B bypassing 댓글 type A SED and L copy paste is B an atomic, we can pass B. We can also use is A an atomic C, C atomic C, atomic C. I defined the concept atomic C for C++20 concept. I defined is atomic B for C++17 because I need this for CUDA programming. Now open up your compiler. CD 028 atomic clang version. I'm using clang version 14.0.4. clang SED C++20 atomic.cpp TBB Chapter or C.exe. CLSC. So is A an atomic? Is A an atomic? False, because A is not atomic. Is B an atomic? Is B an atomic? True, because B is an atomic. Is A an atomic C? We used atomic C concept. False. Is B an atomic? Atomic C? We passed B. True. I would copy this command string. Copy. Paste it here. We will check with the GNU compiler. Hit enter. GNU compiler also works. Copy this command string, paste it here. Now Intel compiler CD 028 atomic DP CPP SED C++20 don't miss EHSC F no sigle atomic.cpp or d.exe. Hit enter. Copy this command string. Copy. Paste it here. Now CLS D. We will test with Microsoft compiler. CD 028 atomic CL EHSC SED C++20 atomic.cpp fe m.exe hit enter. CLSM Microsoft compiler also works. Copy this string, paste it here. Now scroll down, copy from here up to this point. Copy, paste. Here is atomic ref. Is atomic ref. Atomic ref. Atomic RFB ref is atomic RFC, atomic RFB. Now here SED atomic RFC A. This is L value semantic. Scroll down, copy, paste. Is C an atomic ref? Atomic ref. This is C. Copy this, paste. Is C an atomic ref? Atomic ref. This should be C. I will copy this, paste. Is B an atomic ref? Atomic ref. Is A an atomic ref? Atomic ref. Now we build again. Intel compiler works perfectly. Microsoft compiler also builds. GNU compiler also builds. Clang compiler also builds. Clang compiler works correctly because B is not atomic reference, false. C is an atomic reference, true. Is A an atomic reference, false. Is C an atomic reference, true. Please understand that atomic reference, we have to pass an L value A. This is introduced to C++20 standard. Now, copy this, copy, paste it here, test, passing atomic to function. Copy this, paste it here, semicolon. Here, void take an atomic. This is a function. Here, atomic C. We are using this concept to constrain, although it should be L-value reference or forwarding reference. Once again, this does not work. We cannot copy atomic, so this does not work. It should be either L-value reference or forwarding reference. I would prefer L-value reference A. Here, std cout A std enter. Now here, take an atomic. We can pass A. It does not work. If we build, it does not work. It does not build at line 96 because we used constraint. This concept is used to constrain the type of A. If we pass copy, paste an atomic B, it now works. It now works because B is an atomic. We can pass an atomic. We build again. We are using clang compiler. So A is reported 0. We passed B. I would say B because it is confusing. Or we can set 5.6. We build again. CLSC. So we set B with a floating point of type double. It works perfectly. If I remove L-value reference, it does not work. We cannot copy atomic. It does not work. Take an atomic, we pass C. It does not work. C is atomic reference. we put L-value reference. It still does not work. It does not work because C is not atomic. It is atomic reference. I will disable it. Now copy this, paste, take an atomic reference. Then it should be ref. Here, take an atomic reference. Because C is atomic reference, we can safely pass C. Here once again, we used L-value reference. It should work perfectly. CLSV. Of course, we can use forwarding reference. I said we can use forwarding reference. CLSC. Why we can pass forwarding reference? Why? Because SED, cout, the type of V, CPG, get type, category. We pass B, SED, and F. Please pay attention to the type of B. Don't confuse forwarding reference with L-value reference or R-value reference. The type of V is L-value reference. C is named. Named value is L-value reference. We build again CLSC. The type of B is L-value reference. Here, don't confuse with R-value reference and forwarding reference. This is forwarding reference, not R-value reference. Let's try. Take an atomic reference. SED, atomic, ref. We pass A. Now let's try it if it works. CLSC. Now the type of B is R-value reference. This is R-value reference. This is forwarding reference. Don't get confused. Forwarding reference with R-value reference. So this works perfectly. Now scroll up. We will create another function. Template, type name T, context per, bool, atomic, semantic, B is atomic, B, T, or is atomic reference B T. Copy this, paste. It should be concept, atomic, semantic, C. We copy this, paste it here, T. Now scroll down, here, copy this, take as an atomic. I will delete this. It should be atomic RFC. Here we say atomic semantic. So we are using atomic semantic, this concept here. It can take both STD atomic and STD atomic reference. Now here I would disable these. Take as an atomic. We pass B, copy, paste, C, paste, STD, atomic reference, A. Now we rebuild CLSC. So B, this atomic, C, this atomic reference, and I value atomic reference by passing A. A is L value. All works correctly. In my next episode, I will discuss atomic shared PTR. Control-click atomic shared PTR is introduced to C++20. It is very, 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 very useful.